This is a game, landing very hard and strong for the grade 9s today again. Hope my grade 9 people are here. I'll give them a chance. I just need to also share the beautiful. All right, so people, we are revolutionary greetings to all in the live. I hope my grade 9s are here. It is you that I'm looking for. It is you that I am actually here for. And I hope you guys are doing well and swell and amazingly well. Yesterday I did a live on grade 9 straight line functions, and we went a bit deeper into the standard form of a straight line function, the gradient, what gradient is, the fact that gradient is a slope. We looked at the formula for calculating gradient when we are given coordinates or points on a Cartesian plane. We looked at what m means as far as the gradient is concerned. What do we mean when the gradient is positive, the straight line function that is increasing? When gradient is negative, the straight line that is decreasing. When the gradient is 0, the horizontal line. When gradient is undefined, the vertical line. And then we also were able to actually look at other aspects of our straight line function. So we did quite a bit yesterday. And so for all the grade 9s that are here, please guys, okay, sorry again, sorry about that. Had a bit of a glitch there, guys. So like I said, we are back doing straight line functions again. Okay, so I was just recapping on what we did last time, and looked at the standard form of a straight line function. But I think what I'm going to do is I'm going to allow those who did not get a chance to actually go through this lesson with me to actually go and visit the YouTube channel. I have a YouTube channel that's actually posted onto the bio. You can check out my bio. On the link, it's there, so you can always check out what it is that we did on functions on that particular day. So I'll be moving forward today, but just to kind of recap as well, is that we looked at the standard form of a linear function, and then we looked at how when we want to identify what we refer to as the gradient m and the value of c, which is the y-intercept, the gradient m, we can actually first write the equation that we have in standard form. All right, so for instance, this equation is already in standard form. Why? Because it is already in the form y is equal to mx plus c. So if you look at this y is equal to 3x plus 1, we can actually just identify our gradient from the equation. The gradient is 3, so we just write it there. And then obviously the c value, which is the positive one, is actually 1, and so that is our y-intercept. And if you guys remember very well, I said that c, which is the y-intercept, the definition of what a y-intercept is, guys, is simply this. The y-intercept, grade 9s, is a place where the line that we draw, which is a straight line, intersects, crosses, or meets or overlaps the y-axis. Okay, yeah, so that's very important to note. So guys, this function y is equal to mx plus c is a very important function that you guys need to know. All right, and the topic itself, functions, is a very important function in and of itself. Okay, okay, so very important, that one, very, very important, very critical. Okay, so we're going to now go a little bit deeper into functions. All right, so yesterday what we did is we looked at, we also compared gradient, okay, because we noticed that the gradient, which by definition is the slope of a function, or in other words, it is a measure of how steep our function is, all right, our straight line is. Okay, so we then established that if the value of the gradient is positive, then this is the straight line we can expect. We can expect a positive sloping upward straight line. From left to right, the function of the straight line slopes upwards. All right, that's what we can expect when the gradient is greater than 0. If the gradient is less than 0, okay, if the gradient is less than 0, then we can expect that the function slopes downwards. Okay, it slopes downwards. Thank you, me again. It slopes downwards like this. So from left to right, the function slopes downwards. If the gradient is equal to 0, then we have a horizontal straight line. Okay, and then if the gradient is undefined, we have a vertical straight line. Oh man, hi Aiden, that's a funny one. No lasagna, just lasagna. Okay, then of course guys, this here is the different forms of our straight line that we will get depending on the value of m, which is our gradient. Okay, and like I said, gradient is simply the measure of how steep our function is. So the steepness of the function here is that it slopes upwards if it's positive, the gradient. If it's negative, it slopes downwards. From left to right, you can see from left to right the function slopes downwards. If the gradient is 0, then the straight line is just horizontal. There is no evident slope, and the y values are the same right throughout this horizontal line. But if the gradient is undefined, then we have a vertical line. In other words, there's a vertical slope, it's infinitely steep, and there's a constant value of x. In other words, the x value will be the same right throughout this vertical line. So here for the horizontal line, the y value will be the same throughout, whereas for the vertical straight line, the x value will be the same throughout that line. Okay. Then we learned that c, which is the value of c here in our standard form of our straight line function, it stands for the y-intercept. What is an intercept per se? An intercept is a place where, you know, that particular function crosses, meets, or overlaps the y-axis. So the y-intercept specifically is a place where the line, the straight line, will cross, meet, or overlap the y-axis. And we are going to look at that obviously a little bit more closely. Then we looked at what parallel lines actually, they have this significant property. Parallel lines have equal gradients, right? So we spoke about gradient and what it is. So something we note is that all parallel lines, if lines are parallel, then we know that the gradients are equal. You know, that's why, for instance, if you have this line, line 1 and line 2, what we can say is that if these two lines are parallel, as you can see that they are, then we can conclude that the gradient of line 1 is equal to the gradient of line 2. Okay, that's something unique about our parallel lines. Okay, Aiden, functions of the devil. Then perpendicular lines. Well, perpendicular lines, guys, the product of the gradients for perpendicular lines is equal to -1. Okay, so Aiden, you are in grade 11 and you are saying the functions are the devil. All right, and of course they are if there's no foundational solid understanding of functions. So that's why, for instance, I'm busy with the grade 9s now, trying to make sure that with the limited knowledge of functions that they start with in grade 9, which is straight line functions, they have a very good solid foundation, so that by the time they get to grade 11, there's no problems. Okay, so for perpendicular lines, guys, okay, please take note here. So if you look at this, I say the lines that are forming the T shape, okay, because that's what perpendicular lines are. Perpendicular lines, they literally meet at and form an angle of 90 degrees where they meet. So where they meet, perpendicular lines form a right angle or an angle of 90 degrees. We call the right angle an angle of 90 degrees. So this is one line and this is another line. Okay, and you can see that this line, it's sloping upward, whereas this line is sloping downward. So you can clearly see that this line, if it had a gradient, it would have a gradient that is positive, whereas this line, since it's sloping downward, it would have a gradient that is negative. Now if we look at perpendicular lines, we are told that the product of the gradients of lines that are parallel actually equal -1. I repeat, the product of the gradients of lines that are parallel that are perpendicular. Okay, I repeat, the product of the gradients of lines that are perpendicular lines, will equal -1. So that's why we say the product meaning multiplication, of the gradient of line 1 times the product of the gradient of line 2 should give us a -1. All right, now the negative sign makes sense because if you look at this, like I said, you have a sloping upward graph or straight line which would have a positive gradient, but you have a sloping downward straight line which would have a negative gradient, because look at the sloping downward straight line, it has a negative gradient. So of course, if you multiply those two gradients, what you would get is a product of -1. Okay, so perpendicular lines, the product of the gradients of perpendicular lines will equal -1, whereas parallel lines, on the other hand, have what? They have equal gradients. And guys, you know what? You guys are so fortunate, because I'll tell you this: if you are in my live today and you are listening to me say this to you, then you are actually hearing one of the most important concepts when it comes to straight line functions. And if you are a future grade 10 learner who is intending to do pure mathematics in grade 10, then I can tell you this, that if you grasp this concept and you run with it, it will serve you well, not only in the topic of functions, but also in other topics that come up in grade 10, 11, and 12. And I hope that we have grasped what I mean by this, that parallel lines have equal gradients, right? So lines that are parallel will always have gradients that are the same. But perpendicular lines, the product of the gradients for perpendicular lines should give you what? A -1. Okay, so I'm sure you guys obviously will want to make sure that you grasp this thing and you grasp it forever, right? So I remember at some point that, you know, I was sitting, especially during COVID time. I remember during the COVID era, like when we had COVID, you know, like, you remember, guys, how crazy that time was. So my mind also went crazy during that time. And, you know, I'm not someone who particularly loves rap music, hip hop, and all of that stuff. But I remember sitting in my room this one time, and like all of a sudden I started thinking of this whole idea of parallel lines and perpendicular lines. All right. And so as I was sitting there, like I just started having this thing like that was just going on in my head, and I was like, parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients. So like that thing was like just hammering in my head, you know how it is. You're sitting there and you're doing nothing, and then all of a sudden someone like me who is like, an avid maths person, loves teaching mathematics, like I'm sitting there and I'm like, parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients. And I'm like feeling it here because like something is just starting to happen, and I'm like, what is happening here? So I'm like, parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients. Hopefully by me repeating this over and over again, you're like, what is this guy do? What is this guy do? I'm guessing really and truly, like, sometimes even I think I should think that as I was repeating that parallel lines over and over again, I was definitely making TikTok not really like me that much, because I'll tell you this, like for some reason you guys just disappeared off the face of my screen. Okay, so let's not forget this concept that parallel lines have equal gradients. Okay, so in the midst of like having this thing of parallel lines equal gradients like repeat itself over and over again in my head, like all of a sudden like there was this sort of like rough interjection that came through, right, in the midst of me like repeating this thing of parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients, parallel lines equal gradients. And this is what happened. Perpendicular lines, and this was what was happening there, perpendicular lines. And then it was like the product of gradients equals to -1, the product of gradients equals to -1, the product of gradients equals to -1, the product of gradients equals to -1. So that's the thing, eh? Perpendicular lines, I feel that one. Perpendicular lines, perpendicular lines, perpendicular lines. The product of gradients equals to -1. 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 So that is it, guys. Like that one, just don't ever forget. Parallel lines equal gradients. Parallel lines equal gradients. Perpendicular lines, the product of gradients equals to -1. 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 So parallel lines will always have equal gradients, whereas perpendicular lines, the product of the gradients equals -1. So I feel like I've spent too much time on this concept, but like I said, it's a very crucial, critical concept for a learner who is intending to do mathematics in grade 10, 11. You will have to make sure that you never ever forget this one. You need to engrave it in your mind. All right, as a grade 9 learner, you need to engrave this in your mind. The parallel lines have equal gradients, but perpendicular lines, the product of the two gradients for these lines that are perpendicular should actually equal to what? To -1. That is something that you need to note now and forevermore. That is something you need to note now and forevermore. You see, even the car outside is going crazy because it's like the product of gradients equals to -1. 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 The product of gradients equals to -1, guys. So the product of these gradients of perpendicular lines gives you -1 without fail. Whereas parallel lines have what? equal gradients. Parallel lines, yeah, equal gradient, yeah, parallel lines, yeah, equal gradient, yeah, parallel lines, yeah, equal gradients. A perpendicular line, the product of gradients equals to -1. The product of gradient equal to -1. Okay, let's move on. So hopefully we've understood this, that y is equal to mx plus c is the standard form for any straight line or linear function. M means gradient. What is gradient? It is our slope. What is gradient or slope? It is the measure of how steep the function is. Gradient can be identified whenever the equation is in standard form. It can only be identified, the gradient, when the equation is in standard form. In any other form, we know nothing until the equation is in standard form. Then we can identify gradient, the value of m, because m is the gradient when the equation is in standard form. So this y needs to be positive. It has to have a coefficient of 1. The x needs to be on the other side. It has to have an exponent of 1, because that's what makes it linear. Okay, so if there's no number there, you must know that there is an invisible 1 as the exponent. This term here must be in the numerator as it is right now, and then the c value also stands for something. It is not the gradient, but it is the y-intercept, the place where the straight line that we are drawing cuts, crosses, meets, or overlaps the y-axis, and that's very important. Okay, so m is the gradient. If we want to calculate gradient, we are not given the equation, but we are given the points on the Cartesian plane. We can use this formula. M is equal to y2 minus y1 over x2 minus x1. This is a valuable formula to utilize whenever we want to calculate the gradient and we are given the points on the Cartesian plane. And then, like I said, this is the many different types of graphs we get. Whenever m is positive, that's the straight line. M is negative, that is the sort of shape we expect from the straight line. M is equal to 0, horizontal line. M is undefined, a vertical line, right? And I feel like I've been repeating myself over and over again. Why? Because this bears repeating for many learners, because in grade 9 it's new. It's new. So as new as it is, we need to drum it in, all right? Okay. Now, let's look at an example here. If we have y is equal to 3x plus 1, the first question we want to ask ourselves, what type of function is this? All right. So when we look at this, we can see y is isolated on the left. There's an equal sign. There's a 3x plus 1. This 3, what is it? All right. sorry guys, I had to attend to something quickly. All right, so we are back. Okay, let's see this. So what did we want to do here? We wanted to look at this function. So y is equal to 3x plus 1. If we look at this form, this is y, right, is equal to 3x plus 1. So what type of function is this? That's the first question we need to ask ourselves. We can see this equation. This is y, it's isolated. There's an equal sign. There's a 3, there's an x, there's a plus 1, all right? So we can clearly see from this equation that this equation is in this form. Y is equal to mx, the x with the exponent 1, plus c. Remember, the x here must have an exponent 1 if it is to be called a straight line function. Right, so we can see here this is already a straight line function because we can see that the only x value that is here has an exponent that is 1, which we cannot see, which is fine. And then we have a coefficient here of 3, and then we have a plus 1, which is basically the same plus 1 that is in the position where c is. So what type of function is this? This is definitely a linear function. 2. What is the value of m? Find the value of m. So we are given the value of m. There it is. It is the coefficient of x, which is 3. So we say m is equal to 3. What is m, guys? M is what we refer to as the gradient of the straight line function. So that's why we say m is equal to 3. What about c? Well, the c value obviously is our constant term there. So our c value is equal to 1. And remember, what did we say c is? C is the y-intercept. What is the y-intercept? It's the place where the line intersects or crosses, meets, overlaps the y-axis. Right? That's very important. So there it is. C is equal to 1. That is our y-intercept. Okay. If we look at this equation, okay, 8y plus 2x is equal to 16. All right. If we want to find the value, determine the value of c and m, we can see that this equation has an x, but the x is raised to the power 1. But is the equation in standard form yet? No, it isn't. So what do we need to do? We need to actually take this equation and make it into standard form. How? Well, what we do first is we write down the equation as we are given. 8y plus 2x is equal to 16. Then we need to isolate the 8y. Okay, on the left we have how many terms on the left hand side of this equation? We have 1, the plus sign separates the terms, and then we have a second term. So what we do is we take the 2x over to the right hand side, and when we take the 2x and transpose it to the right hand side, what changes? The sign of the term. So from positive 2x it becomes negative 2x. This 16 was already positive already, so we have now negative 2x plus 16 on the right hand side. Then next step, we divide the what? The coefficient. Divide by the coefficient of 8y. We divide by 8 for this term, but what we do on the left we must do to the right side for each term. So we divide by 8, the negative 2x we divide by 8, we divide 16 by 8 as well. All right. Why are we doing that? It's because we want to isolate the y value. So we divide each term by 8, which is the coefficient of y. So whatever the coefficient of y is, that's what we divide each term by. All right. You should know this obviously from where? From equations. When you did equations in term 2. All right. Then what do we now have? Y is equal to negative 2x over 8 plus 16 over 8. If we simplify negative 2 over 8, it gives us negative 1 over 4. And then our x is simply the variable. All right, plus what? What's 16 divided by 8? It gives us 2. Now what do we see? We can see that the equation is now officially in standard form. So if it is in standard form, what is the coefficient of x? We now have the coefficient of x as negative 1 over 4, which means what? Our m value is negative 1 over 4. It also then means that our gradient is negative 1 over 4. What is our C value? Our C value is positive 2. Our C value, our constant term, is positive 2. Right? So this is how we are able to identify the gradient. Okay? And I want to just note that this, guys, is the gradient because it is the m value extracted from the equation in standard form. And this is the true y-intercept because it is the C value extracted from the equation in standard form. Okay, I hope you understand this, guys, and that's very, very important. Okay, all right. Then yesterday as well, we looked at how to find or identify the gradient when we are given points on the Cartesian plane, or if we are given points just generally. So here we had some questions: determine the slope, determine the gradient between negative 2 and 1 and 3 and 4. How do we calculate the gradient between 2 points, negative 2 and 1, 3 and 4? So yesterday what we learned is that whenever we are calculating the gradient, it is important first and foremost to write down the points that we have been given. So there's a negative 2 and 1, 3 and 4. So this first point here, negative 2 and 1, we say this is our first point. Okay, please guys note that when we were given the points, negative 2 and 1, 3 and 4, we weren't told that this is the first point, this is the second point. We ourselves allocated that this is the first point and this is the second point. As such, I said 1, 2. This being the first point, it means that here inside the brackets, I have the x coordinate, or my x value for my point, and the y coordinate, or my y value for the point. So my x coordinate, I'm going to call x1. Why am I calling it x1? It's because this is the first point. Then my y coordinate for my first point will be called y1, because this is the y coordinate for the first point. Then this is my second point, 3 and 4. My x coordinate is 3, my y coordinate is 4. So I'm going to call it x2 and y2 because this is my second point. Make sense? I hope it does. Now, all I simply do is I write down my formula for gradient. M is equal to y2 minus y1 over x2 minus x1, because this is the formula that I use to calculate what? Gradient when I am given points on my Cartesian plane. So y2 minus y1 is the formula. At the top, we always talk about the change in y. Please guys, never the change in x at the top. Y is at the top, please. And then at the bottom, in the denominator, we talk about the change in x. All right. So our y2, where is our y2? Our y2 as allocated from the choice of points, our y2 will be 4. Okay. Then what is y1? Our y1 will be 1 as chosen from the points. So we are going to say 4 minus 1 in the numerator. Why? Because the formula says so. In the numerator, we subtract our y values, but in order, guys. Y2 first minus y1. The bottom, x2 minus x1. So the order is very important. We start with the 2's for the respective values of y and x. We end with the 1's for the respective values of y and x. That's very important. We do not ever mix up the order. We must make sure if we start with the 2's, we end with the 1's. Start with the 2, end with 1. If you start with the 1's, you end with the 2's. Okay, we could say y1 minus y2, but we must then say x1 minus x2 if that is the case. So we start with the same thing, we end with the same thing when it comes with the numbers. All right, please note that. So 4 minus 1 over 3. Remember, the formula already has a minus sign, and my x1 is also negative. So in brackets, I put the negative. All right, so then I have 4 minus 1 at the top. What's 4 minus 1? 4 minus 1 is 3. Then at the bottom, I have 3 minus minus 2. Remember, guys, that the formula had minus, and then my number x1 is also negative. So what's a negative times a negative? I must remember that because brackets mean multiply. What's a negative times a negative? It is a positive. So that's why I have in the denominator 3 plus 2. Then what's 4 minus 1 in the numerator? It's 3. What's 3 plus 2 in the denominator? It's 5. So my gradient for this point, these 2 points, gives me 3 over 5. Is this a positive value? Yes, it is. And as a positive value, it means if I was to draw the straight line for this function, it would be a sloping up function, because we already learned that if the gradient is positive, we can expect a sloping up function from left to right. Okay. Simple, right? Using the formula. How to calculate the gradient using the formula? Very straightforward. The formula is there. We simply need to identify our points, and then we go ahead, we substitute into the formula, and then we get our answer. Okay. Yes, Diamond. It has to be negative y2 minus y1. We are subtracting the y values, subtracting the x values in the appropriate order. If the order is 2, then it's 1, 1. Please, guys, we are subtracting, not adding. Never adding, okay? But subtracting. I hope that makes sense. All right. Okay. If we look at another example, guys, another one, we have the next problem. The 2 points that we have 4 and 1. We have 4 and 5. So our first point, all right, which we allocate ourselves, we say this is our first point. That means that's x1 and y1. Our second point means this is x2 and y2. Please take note of something here. What do you notice about the coordinates of these points? This is 4 and 1. This is 4 and 5. Tell me something that you particularly notice about the coordinates of these points. We have the x coordinate, the y coordinate. That's for the first point. We have the x coordinate, we have the y coordinate. That's for the second point. Anything that you notice from the coordinates of these 2 points, because you see the coordinates of these 2 points, it was negative 2 and 1, 3 and 4, right? I'm sure you noticed that these coordinates, they were very much different. But something is very interesting about the coordinates of these 2 points. What is it that you notice about the coordinates of these 2 points? Anything out of the ordinary, or anything that you feel like is very interesting about the coordinates of these points for 2? What do you notice, guys? Anything? Or nothing? Yes, you were very nice. The x coordinates are the same, guys. Look at x1, it's 4. Look at the x2, it's 4. So the x coordinates, they are the same. All right? But the y coordinates are what? They are different. So you must note that thing. X coordinates are the same. So immediately in your head, okay, yeah, the difference between the y coordinates is 4. Okay, very true, very true, very true. Okay, if you are starting with this one and that one, very true. But what I wanted you to just notice from these coordinates from the get-go is that the x coordinates, they are the same, whereas the y coordinates, they are different. So that being the case, all right, that being the case, you should surely expect something to be happening if I was to now substitute these points onto my formula. All right, so there are the points again: 4 and 1, 4 and 5. 4 and 1, I'm going to say is my first point, therefore this is x1, y1. This is my second point, so I'm going to say this is x2, y2. So let's go to the formula. M is equal to y2 minus y1 over x2 minus x1. y2, I substitute, it is 5. y1, I substitute, it is 1. So I have 5 minus 1 at the numerator. Let's go to the denominator. I go to x2, it is 4. I go to x1, it is also 4. Then I say 4 minus 4. All right. Oh, thank you so much, Mrs. Im. I really appreciate this. So generous. Thank you. Thank you. Thank you. 25 you awesomes and 19 GGs. I really appreciate. The GGs are for all my geniuses in the live, my GGs. I've learned from my learners that every time they witness that there's someone in the classroom who is particularly smart or particularly excellent in mathematics, they just go ahead and they say EGG. So I think that GG, the 19 GGs that you sent are for my 45 viewers that are on my live, the viewers that are getting the sweet marks, the ones that pass so well, and the ones that the learners seem to always, reaffirm and say EGG. That definitely is for the geniuses in my life. So thank you so much for the GGs. And then definitely the 25 you awesomes are for the all you awesome people that are on my live as well, including you, Miss Im. I really appreciate it. Thank you so much. Okay. Yeah, thank you for your generosity. It is very much appreciated. So now here in the numerator, guys, if we substitute, you see y2, there's 5 there. You see, must make sure that you plug in the values that you've identified. We don't want to be making a mistake here and plug in wrong values in the wrong place. Yeah, you must send people in the right place, guys, because if you send people in the wrong place, you are going to butcher this thing. So y2, he must make sure when I plug him in, he's in the right place. There y2 is, yes, it's 5. The sign that follows is minus. It is already there in the formula. Y1 is positive, so I just put 1, okay, there, because a positive and a negative just keeps the negative, so I put the 1 there. Then x2 is 4. I just write 4 minus x1 is 4. Okay, does that make sense? So 5 minus 1 is 4. 4 minus 4 is 0. What is a number divided by 0, guys? Now in grade 8 already, in term 1 of grade 8, when you did whole numbers, you guys were told that division by 0 means this. What does it mean? It means that it is undefined. Okay, so yes, Ayabonga, we leave the answer like this because 4 divided by 0 is undefined. So m is undefined. All right, and we did establish earlier on when we were talking about m that sometimes our m value, our gradient, can be positive. This is what we expect from our straight line. Our gradient can be negative, less than 0. This is what we expect about the shape of the straight line. It's sloping downward. Our m value can be equal to 0. It's a horizontal straight line. But if m is undefined, we expect to have a vertical line. All right, and that's very important. So this here is an indication that if we were to sketch this function, we'll have a function whereby the straight line is vertical. Okay, so yes, we leave the answer like this. All right, I hope that makes sense. Okay, do I have a picture of those notes, Ayabong? Yes, the pictures of the notes, there they are. I actually, like I said in the live lesson I did yesterday, these notes were explained. So on the link in my bio has that link where you can actually go and check out. I uploaded the video of the live lesson I did yesterday, so it's there. Okay, so yeah, these notes are very critical and they are very key. All right, very, very, very important. And maybe just to there we have it. All right, there it is. Okay, very, very nicely put there. M is equal to the formula when m is positive, m is negative, m is equal to 0. That's what we are talking about. Okay, and then what we spoke about just now with the c value, y-intercept, place where the line intersects the y-axis, parallel lines having equal gradients, and perpendicular lines, the product of the gradients being equal to -1. So those are just nice brief notes. And additionally, on these notes, what I did is I added the idea of m being undefined. Okay, m being undefined. Okay, m being undefined. If m is undefined, then we have a vertical straight line. So that is something now that I've actually added on so that people can even know about this as well, and they are not shocked when they experience such a situation. Deleke, I don't reveal all my secrets, unfortunately. M is equal to y2 minus y1. Let's look at the next point here. So the last concluding point here, we have 2 and 3 minus 5 and 3. So when we are looking at 2 and 3 and minus 5 and 3, what do you notice about these points? Okay, so from this question here, it should give you a conclusion that whenever you are calculating the gradient of 2 points and you find that the x values are exactly the same, then that means that you are going to experience a situation where the gradient is undefined. Okay, that means you are going to always experience a situation where the gradient is undefined, and that's very important for you to note, and I want you to note that. All right, now let's come here. You must note something about this point, 2 and 3 minus 5 and 3. What do you notice about these 2 points, 2 and 3 minus 5 and 3? Okay, ASRH at says, so if we want to calculate mx plus c, of course we will get there. For now, I'm just looking at calculating m. Remember, this what I'm doing here is step by step, so you guys need to be patient with the process. All right, we will get there. We are currently trying to make sure that we have no confusion about how to get the value of m. Thank you so much, Lesejo, in the comment section. The y coordinates for these points, they are the ones now that are the same. You have identified exactly. Yes, Yadeleke, you are 100% correct. The y values are the same. Okay. Ayabonga. Let's see what will actually happen. Remember, for number 2, it was the x values that were the same, and therefore that's what led to our gradient being undefined. Now let's check now. If it is the y values that are the same, what is going to happen with our gradient? So let's go and check. So here is our gradient formula. M is equal to y2 minus y1 over x2 minus x1. So our points are 2 and 3, and then minus 5 and 3. So we are going to choose ourselves. You can decide, and it doesn't matter, guys, which one you decide to make the first or the second point. At the end of the day, you will still get the same answer. So I decided to make this one the first point. So since this is the first point, it means this will be x1, this one will be y1. Then this here is the second point, so that means this will be x2 and this will be y2. Does that make sense? Yes, TK. Yes, TK, that's true. So if we go ahead now and substitute into our gradient formula, what happens? What's y2? Y2 is going to be my 3. So I substitute 3. Then I write my sign in the formula, minus. Y1 is 3 as well. So I have in the numerator 3 minus 3. So it's only in the numerator that I'm going to experience a subtraction of 2 values that are the same in the numerator. In the denominator, I have different values. So of course, I'm going to say x2 minus 5, followed by the sign in the formula, minus, followed by what? Positive 2, minus 2. So what's minus 5 minus 2 in the numerator? In the denominator, I have negative 7. What's a number? What's a 0 divided by a number? 0 divided by a number gives us a what? A 0. Very different from what we had here. Here it was a number divided by 0. That is undefined. The answer here is not 0. Even if you put this in your calculator and say 4 divided by 0, you are going to get a message on your calculator that says maths error. That message means for division by 0. It means undefined. Let's never forget that. Undefined. Here in this situation, since the 0 is in the numerator, 0 divided by a number is 0. Okay? It's 0. That means our gradient is 0. Our gradient is 0. Are we together, guys? I hope we are together here. I hope we are feeling this one. Our gradient, guys, is 0. It is 0. All right? So that's something we need to now capture. That if ever our y values, they are the ones that are the same. we can expect a gradient that is equal to 0. So what kind of straight line are you expecting to see as you sketch the straight line that has a gradient of 0? You are expecting to sketch a straight line that is horizontal, because whenever the gradient is 0, yes, Yateleki, thank you so much. Whenever the gradient is 0, you expect to sketch a straight line that is horizontal, as opposed to the straight line where the gradient was undefined just a few minutes ago. When we calculated the gradient, we're expecting to sketch a straight line that is vertical. All right, please guys note this thing. And a horizontal straight line has no slope because it is not sloping up or sloping down. It is horizontal. Okay, very important. Yes, in other words, who is staying constant? It is the y value for the horizontal line that is constant. But for the vertical line, it is the x value that is constant. Okay, here we have no slope, but here we have a vertical slope. Infinitely, it is steep. It has a constant x value, the vertical line, when the gradient is undefined. But if the gradient is equal to 0, there is no slope, but our value of y is constant, meaning it is the same throughout this horizontal line. Okay, yeah, these are key concepts. Okay, key. All right, so I hope we are getting something from these explanations. All right, and all I'm doing here is I am unpacking the concept. Okay, so today I'm going to look at sketching the graph of a straight line. Before we get into anything else, I want us to look at how do we sketch the graph. And to begin the process, we are going to look at y is equal to let's say 3x compared to y is equal to negative 3x. All right, now something you should note very quickly is when you look at this equation, what type of function is this equation giving to us? We need to always ask that question so that we know very well what type of function we are dealing with. So if we look at the equation itself, this is y is equal to 3x. All right, and it seems like when we are looking at our c value is what exactly? Right, so I'm going to start by looking at this function. This function is y is equal to 3x. What type of function is this? Well, our standard form is saying that, this is it, Melanin. Our standard form is saying that y is equal to mx plus c is a straight line. If this is in this form, then this is our standard form for our straight line or linear function. So this is in this form. Indeed, y is equal to 3x. Our x value is in the numerator. The exponent is 1, invisible as it may be. The m value, meaning our gradient, is 3. So what we are expecting is that when we sketch this thing, we are going to see a shape that is of this nature. I already know, I can anticipate the shape of the function even before sketching it when I look at the equation in standard form. So in standard form, I can anticipate what sort of shape my function will be in if the equation is in standard form. Guys, it's so important to always have our equation in standard form. So since m is equal to 3, I know what the shape of the straight line will be like. Make sense? Then, since I know that m is equal to 3, what about c? C is equal to, let me see if people in the comment section can let me know. What is the value of c? Remember, the straight line function y is equal to mx plus c. What is the value of c in this situation? Do we know? Y is equal to 3x. Thank you, Sia. and Ivile and TK. Yes, C is equal to 0, guys. All right, it is indeed equal to 0. Now, having said that, that means our y-intercept is equal to 0. In other words, what is the y-intercept? What did we say is the y-intercept? We said this is the place where the line that we are sketching intersects. What does the word intersect mean? It means that's where the line crosses, meets, overlaps our y-axis. Right? Yeah. So that means this straight line will overlap the y-axis at where C is equal to 0. Right? And that's very important. Very, very important. Now, if C is equal to 0, we always use the table method to sketch function. We always use the table method to sketch the graph. Right? Now, this is very, very important. If C is equal to 0, we always use the table method to sketch the graph. Guys, and this is the only situation where using the table method will assist us in being able to see the function and how it looks like. We just need the table, right? So, what do we mean by table? So I'm going to write number 1, right? So sometimes it happens that when they give you a function like this, they will tell you exactly the sort of values of x. Okay, they will tell you exactly the sort of values of x that you need to use when you are sketching that function. Okay, what rule? Thanks for letting us know. It's my first time hearing the rule. Are you talking about this one? Yeah, because people waste their time with the dual intercept method and then they get 0 and 0 and they're like, what do I do? Right? Please, guys, whenever C is equal to 0, if C is equal to 0, we always use the table method to sketch the graph, right? So what we then do, and I think very easily, is we know our x values belong there, all right? Remember, when you did the flow diagram, functions and relationships, the flow diagram, you guys did the table method. You would put x there, you would put y there. So what you do is you simply do yourself this favor. You write down -1, 0, and 1. Just that. Okay. So you make life easy for yourself. Sometimes they give you the values of x that they want you to actually utilize in your table, right? So you always check if they've given you x values, or if they have not given you x values, when you know immediately if C is equal to 0, table, you need to go to the table and use your table method to actually sketch the straight line function. Now, all you do is you take these respective x values and you substitute them into your rule. Remember, this is a rule. 3x is a rule. So if you want the y value, you simply take the x, you put it in, because these are our input. Remember, we did this. This is input, output. Input, the rule has the value that is the variable for the input. The rule itself has the input. The x value is the input. The output is y. More formally known, we say that this is an independent variable. You'll hear your teachers speak about the fact that this is an independent variable. Right? Please, guys, more formally known, right? Independent. This one, y, is a dependent variable. Dependent. And let me just make an example. All of you minors in my life, the kids, You are all dependent on your parents for food, for money, for water, for resources, for everything. You are all dependent. So you are like, why? You wait for something to come in. You can only produce something once something comes in. So if I take the negative 1 and I substitute it there in the place of x, what's 3 times negative 1? You see, you only get something out once something from your parents comes in. Independent. Your parents are independent people. They're very independent. They are very independent. These people, you know, they make the money, they bring the food. You also like know that, hey, you know, these people are not around. It's problems. So that's what I want you guys to remember. X is like your parents. Y is like you. Right? Any input is like your parents. Any output is like you. All right, let's just keep it like that. Okay, so -1 and -3. All right, but I want you to note that this is a point that we can write x coordinate -1, y coordinate -3. So from this substitution of -1 in the place of x, I get an output, and I can write it in. We call these ordered pairs, right? Also known as coordinates, you know. And I'm just giving you terminology as well, so that you guys also have the more formalized terminology, you know. Input, not just input, independent variable. A variable, you know, is a letter of the alphabet, okay, that stands in the place of something that we do not know. Y is the dependent variable, okay. Y depends on x. That's why we say y is a dependent variable. If x is not put in, y will not have a value. That's why we say y is depending. Just like the son depends on the parent, the daughter depends on the parent, y depends on x, not the other way around. X, on the other hand, is independent, does not need y. You see, very key. But they are in a relationship. Hence we talk about functions and relationships. They are in a relationship, a dependent and independent relationship, if you want to call it like that. When you substitute 0, take the 0 there. Remember 3x, 3 times 0. What's 3 times 0, guys? What do I get here? What do I write here? Tell me. 3 times 0. I will get what here? Thank you, Tato. Thank you, Kanya. 3 times 1. I substitute 1 there. What do I get as an output? 3 times 1. Thank you, Tato. So here are my ordered pairs. I have -1 and 3. I have 0 and 0. I have 1 and 3. Now, I could write other x values and continue on and on and on and on. But honestly, people, all I need is a picture, right? Though limited it is, just I want to have an idea of what this function kind of looks like, all right? So this is the first thing you need to do when sketching a straight line function, okay? I hope we are feeling this thing here, all right? And remember, what did I say? I said we do this when the C is 0. We use the table method to sketch the graph, okay? We can either choose arbitrary x values. This word, arbitrary. Yeah, guys, this is a very important, this is a common word that they like in mathematics. Arbitrary. Arbitrary just means random. Random. Okay. Just select random values of x. But you see, they help me to have a picture. -1, 0, and 1. And then I just substitute them in my x values and I get my outputs. Okay. So now let's see. After using the table, I get my ordered pairs. Then step number 2, I draw my system of x's. but most when you do this, you use a nice ruler, guys. Remember, my one hand is busy. It is holding on to my device. So you would use a nice ruler, sketch a vertical line, which I want to now explain. This is the y-axis, and then this one is the x-axis. All right, it has real numbers on it. All right, please guys, it has real numbers. It's a real number line. So here we have 0. We call this part the origin. The origin. The word origin means where things begin. All right, so we call this the origin. So on my x-axis, okay, please guys note, just because I'm writing 1, 2, 3, okay, there are numbers in between 1 and 2, and this x-axis is supposed to represent all of those numbers. Hence I'm saying that the x-axis is a system of real numbers. It's not a system of integers. All right, it is a system of real numbers. And by real numbers, what do we mean? It means all the numbers in the number system. And all the numbers in the number system, they come all the way from negative infinity, all right, to all the way to positive infinity. So there's an endless number line that extends from left to right. These are negative values of x, because this represents negative values of x on the right, on the left hand side of the origin. So on the left hand side of the origin, these are x values that are negative. But on the right side of the origin, we have the x values that are positive. Guys, we call this, the entire system of x and y values, we call this the cart, like cart, C-A-R-T, Esian, E-S-I-A-N, plane, because it has a horizontal plane and a vertical plane. So it's two-dimensional in nature, horizontal plane and a vertical plane. So we call it the Cartesian plane. It's a system of y and x axis, and it contains real numbers. Hey, yo guys, you are being taught here like crazy. On TikTok at 9:23, negative values down here. All right. Now, of course, when we do this, we would do it in such a way that from here to there and from here to there is the same. So if you measure a centimeter from here to there, please keep it centimeters, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter. Same thing here, 1 centimeter, 1 centimeter, 1 centimeter. What you want to do is make sure that the distance from 0 to -1, all right, is the same for your measurements, because when you begin to identify the points that I have actually found from my table, those points, when I connect them, need to actually produce a straight line, not a dot to dot line that is not straight. If it is not straight, then boo hoo hoo to you. Does that make sense? If it is not, if it's like this, I boo hoo hoo, guys, boo hoo hoo, boo hoo hoo hoo. All right. So I hope we get the point. Please. So when you sketch functions that have these, when c is equal to 0, and you have to choose arbitrary values of x, and please guys, stick to 0, -1, and 1. It just makes life easy. Don't try and complicate life here. Okay, unless they have given you a table. Sometimes they give you a table and sometimes they suggest values of x for your intended straight line graph where c is 0. When they've suggested values of x, then you have to stick to those values of x and utilize them and find your output values. Write down your ordered pairs and then draw your Cartesian plane and then identify those points. Now let's see, how do we identify these points? Because that's where the magic lies. Okay, we saw how we got our output values, right? I'm sure all of us did. Now let's see, how do I identify the points? We have 0 and 0. Where is 0 and 0? Where x is 0 but also y is 0 at the same time. Where is that? Where x is 0, I want you to note, guys, that where x is 0 is everywhere on this vertical line. Where x is 0. X is 0 here, x is 0 there, x is 0 there. It's everywhere on this vertical line. X is 0. All right? X is equal to 0 everywhere on this vertical line. So our y-axis is a typical x is equal to 0 line. But where is y equal to 0 simultaneously? Now, let's look at x is equal to 0. X is equal to 0 is this line, all of it. What about y is equal to 0? Y is equal to 0 is the entire x-axis, all of it. Guys, okay. The point itself is where these two meet. Where do they meet? So if the y-axis represents x is equal to 0 and the x-axis represents y is equal to 0, where do they meet? They meet there at the center, guys. So that means here at the center, this is where we call, this is the point that we call 0, 0. So I'm marking that point as a point where I'm going to cut or pass or cross or overlap the what? The y-axis. Because that is my y-intercept. Guys. Yeah, this guy, okay, let's look at this one. Okay. Why doesn't each point represent its axis? It does, as I said. Okay. 0, 0. The coordinate represents each axis. So this is x. X is equal to 0, guys, represents the y-axis, all of it. So whenever you're talking about x is equal to 0, you're talking about the entire y-axis, right? The entire y-axis. When you are talking about x is equal to 0, the entire y-axis is x is equal to 0. But the minute you say y is equal to 0, then you are talking about the entire x-axis, all of it, okay? But then when you talk about 0 and 0, you are talking about where these two meet, meeting of x and y axis. Now you have to ask yourself, where do both of these meet? In other words, where do they intersect? Where do they overlap? Where do they cross each other? It's there. So that's why we say that is 0 and 0. This here is what we call the origin. The origin. 0 and 0. Okay. So I hope even for people that are here that are like in other grades, because I know some people, they come here and they're like, man, I've been in this grade for the longest time. I never knew. Because people don't know basics. And that is the problem with mathematics, guys. When basics are not understood in maths, it's a pain. When you have surface level knowledge of mathematics, what happens is that you cannot retain that information longer. But if you have deep understanding and knowledge of mathematics, that's what actually facilitates excellence, future excellence. because now you can start having a sort of like a good emotion of understanding in your heart about the subject. And when that happens, sure, who can tell what could happen, right? Okay. Yeah, and I love that, I think maths gamers are getting into the mindset of like 100% is possible, and some of you are getting into that mindset of 100%, 90s, in your term performance, because you have this deep, rich knowledge of maths, which is good, and I want you to maintain and cultivate that. Be someone who is even interested. You can use these AI and AI, Google search engines, and you can dive deep into your knowledge and understanding of these things. Ask the questions that you would want to ask your teacher, and ask it to ChatGPT, for instance, and get the knowledge, get the deep knowledge of the maths, and get excited and interested in the subject matter. You'll see. You'll flourish. You'll be the one that flourishes. You'll be the one that will enjoy the marks, the benefits of all of that. So yeah, and it will also help you. Maybe in future, I don't know, maybe some of you are going to become intense mathematicians, or intense people that are going to use the subjects to revolutionize thought and thinking of other things in the future. So do that. Okay, so guys, sorry, I was getting back to 0, 0, the origin. I hope we understand why we say 0, 0 is there. Then let's move. -1 and -3. Guys, let's go and fast. Where is x is equal to -1? Guys, I need you to understand that x is equal to -1 is here. I also need you to know that when I say x is equal to -1, I'm talking about a vertical line that cuts through. That's a vertical. Because everywhere on this vertical line, x is equal to -1. I need to go back here, guys. Remember when I said you have a vertical line? I then also mentioned that the vertical line has a gradient that is undefined. The value of x is constant on a vertical line. So if I am saying that the value of x is constant, it means the value of x is the same throughout this vertical line, right? So if I say to you that x is -1, okay, that in itself is an equation that tells you that x is equal to -1 is everywhere on the vertical line I would draw through -1. It would be a vertical line through this, okay? So, but to be specific, x is equal to -1, we are talking about everywhere on this line, all right? Okay, I hope you understand that. Then, what about y is equal to -3? Where is y is equal to -3? It is there, right? It would be everywhere on this horizontal line, because y is equal to sorry, that's not -3, sorry. You see, getting carried away into nonsense. Y is equal to -3 is here, guys. Y is equal to -3. That would be everywhere on the horizontal line, through this line, through this line, through this line. Y is equal to -3. Through this line, y is equal to -3. That would be y is equal to -3. So if I am saying x is equal to -1, please understand this. Look at this. Look at this. I say where they meet. Where are they meeting? So imagine lady -1 is about to get married. So after the marriage, lady -1 leaves her place of residence and goes and meets who? Mr. -3. Where do they meet? There. This, guys, is the point -1 and -3. Okay. Remember what I said to you guys. I said x is equal to -1 is everywhere along this line, this vertical line. Then y is equal to -3 is everywhere along this horizontal line, passing through negative 3. Are you with me? But where now do these two meet? Negative 1, negative 3. We meet there. Hey, I hope you get me, guys. I hope you get me. So that is the point, negative 1 and negative 3. Okay? Then let's go to 1 and 3. Where is 1? X is equal to 1 is there. But remember, x is equal to 1 is everywhere on this vertical line. Everywhere on this vertical line. Where is y is equal to 3? Y is equal to 3 is there. But remember, the line y is equal to 3 is everywhere on this horizontal line passing through 3. Where are these two meeting? Everywhere y is equal to 3. Everywhere x is equal to 1. Mr. 1 leaves his place of residence. Mrs. 3 leaves her place of residence. And they meet at the restaurant. That is the point. 1 and 3. Guys, do you see my points? This is how we mark the points on the Cartesian plane. I need you guys to understand that x is equal to 1 is a vertical line passing through 1. And y is equal to 3 is a horizontal line passing through 3. Where do these two meet? There exactly. That is the point. All right. Please, guys, all of these things here that I've drawn here are just ways of me identifying the point. Do I have to do these things when I draw? No. I just want you, I did this so that you could see where the point actually is. And all you do, guys, is you take your ruler after doing this. Take your ruler and you simply draw a straight line. A straight line all the way passing through that point, that point, that point. And you can just extend it further than that point. All right, slightly further, because remember that if I had other values of x, you would see the corresponding y values for each and every point. So that is just a representation of the continuous nature of this line, all right, on both directions. I hope that is clear for all of you. Hey, I hope that is clear, guys, for all of you. Yeah. Let us see what Nita wants to say. NITTA. Hello, NITTA. Okay, so I guess that was a false invite. Or okay. All right, I think that was a false invite. So I hope you guys get the point though. Ne? Are we clear? Clear? So this is when C is equal to 0, our straight line. All right. And do you see that the shape we had expected resonates with the points that we actually got from our table, how they are formed, because really the straight line as we draw it using our ruler, we are clearly going to see, oh yeah, it is indeed a straight line. All right. And please, guys, we use a ruler. We connect this. Use a ruler, please. All right. And extend it further. Draw a straight line there at that end. All right. Just so that people can see. And there it is. Then you label it. Y is equal to 3x. Done. Our points are very clear. They've been marked 1 and 3. Whoever is marking my work, the 0, you can see my point there. You can see my point there. All right. And there it is. Okay. I hope you guys understand and you are very much clear with this. So this is how we sketch a function whose C value is 0. And now we can see that, oh, we initially said that C is equal to 0 is the y-intercept. And truly, this function does cut through the y-axis, or it passes through, it crosses the y-axis where where c is equal to 0. You can see that. You see, it's very clear that that is the case. There's no misconceptions about that. So I want to just recap again. I said to you guys that when y is equal to 3x and the c value is 0, you can clearly see that in standard form, m is equal to 3. So this is the shape. I mean, in my head, I begin with the end in mind. I already know that's the shape I'm going to expect, because my m value, when the equation is in standard form, is 3. It's positive. So there it is, an increasing straight line. C is equal to 0. So my y-intercept is 0. Now, I said to you guys that if c is equal to 0, we always use the table method to sketch the graph. So what we do is we just draft up a nice table. We write negative 1, 0, 1. If we have not been given points, we write down negative 1, 0, and 1. And then all we do is we substitute negative 1, we substitute 0, we substitute 1, we find our corresponding y values. So our input values give us our output values. Then we can write these pairs, negative 1 and 3, 0 and 0. 1 and 3 ordered pairs, our coordinates. Then we sketch our Cartesian plane. Then we go and locate origin first, other point, negative 1, negative 3, where we meet. Remember, place of meeting, Mrs. Lesejo and Mr. They meet. Mr. and Mrs. They meet. Then we can sketch our straight line through. And it makes sense, guys, because I was expecting this kind of shape, because I know my work. I know when the gradient is 3, then obviously this is the shape. So it makes sense, Everything makes sense because I have understanding that informs why this is like this. And I don't even need the teacher to confirm, because I know what I'm doing. And it's 100% accurate. Okay. I'm going to do one last. TK is like referred to the notes. These ones. Yeah, these are my, what you might call, it's my copycat notes. What you might call, it's the mpago that, people usually carry, You need to make sure that you have your mpago readily available. These are the kinds of things that need to be up on your wall. Take down Beyonce. I told you guys, take down Beyonce, take down Uzinga Malo, take down all these people that you have there on your wall. And you start posting up these quick short notes. You know, the kind of notes that, okay, I'm bound to forget. Post them on the fridge. Post them behind the door to the toilet, so that as you sit there and as you ponder upon life, and as you allow yourself to actually take the trash out, you can also allow good knowledge to come in. These are things that you need to have readily posted. Most by in term 3, you're going to be writing a control test on, this thing and geometry. So you might as well have the things that will be there, and even for other subject areas, I had a learner, for instance, who's been on my TikTok lives, and who's been watching some of my videos on the YouTube channel, send me his report today. I was very happy. I'm not gonna lie. The learner in question basically has also been commenting a lot on my YouTube videos. After he watches the videos, he'll comment on them and stuff, and I've been seeing his comments for quite some time now. So today he sent me this lovely message, and he was like thanking me for the live lessons, but also at the same time showing me the report. And I was looking at the report, the entire report, not just the maths, guys. The maths was level 7, clean, not a doubt. But I looked at the other, subject areas, and I was like, this boy is doing level 7 stuff, even in other subject areas. And I was like, yo, aye. That is hard work at its best. And you can see, learner dedicated to his education, no doubt. So, I mean, that's good. And I really appreciate that. I can see some of the things that we've been talking about in many a times in the platform are also resonating with him. So let's do one more. I want us to do one more. 2y minus 3x is equal to 6. Here they are saying to us, sketch the function. Now, I want to say that with this one, all right, we don't necessarily need to use the table. Neither do I advise using the table. Here, there is one method that we need to be introduced to, which I want to speak about, which we call the dual intercept method. What do we call it? The dual intercept method. The word dual has to do with two. Intercept, we know what intercept is because we've been speaking about the line cutting through a certain axis. All right, so that means we have two intercepts because we have two axes. Two intercepts because of two axes. Okay, now we have one, the x-intercept. In other words, we are talking about, when we say x-intercept, we are talking about where our line cuts, not the y-axis, but the what? The x-axis. Where the line cuts the x-axis, right? This is called the x-intercept, where the line cuts the x-axis. Okay, then the y-intercept, obviously we've spoken about this one, where the line cuts the y-axis. Right. So I like what my dear beloved friend there in the comment section, if you check this out, Aluncedo has then said in the comment section, don't we? So we don't have to fix it into standard form. Now, listen to me and listen to me well. You don't necessarily have to fix it into standard form, but since we have gotten into this groove of doing so, we are going to do so. All right, all right. Since we have gotten into this groove of fixing it in standard form, we are going to do that so that we can see what we are dealing with. But let's look at this. We have 2y minus 3x is equal to 6. So our first step, let's get this into standard form. So 2y minus 3x is equal to 6. Okay, what's the next step? You guys tell me. You tell me what to do next. 2y minus 3x equal to 6. This is not in standard form, but we want to do so. In other words, we want to isolate y and make sure that it is in standard form. So what is the next step, guys, after 2y minus 3x is equal to 6? What do we do next? We. And I'm going to end after this particular dual intercept. Transpose onto, very good. We're going to transpose, no, not transpose 6. But we are going to transpose definitely, but definitely not going to transpose the 6. Already the 6, if we transpose it, we're not going to be getting it into standard form. We want to get this into standard form, guys. Remember? So we are going to transpose, but I need to understand. Yes, transpose negative 3x to the right-hand side. Very true. What happens when you transpose negative 3x to the right-hand side? This becomes positive 3x plus 6. Then what do we do next? Because the y is not fully isolated, has a coefficient of 2, and we'd rather have it have a coefficient of 1. So what do we do? You tell me, guys. What do we do from here? Huh? Thank you, Sia. We divide by 2. Look at this. As we do this like pros, our equation will be y is equal to 3 over 2. The x plus 6 divided by 2 is 3. Right? So there we have it. Y is equal to 3 over 2x plus 3. This is the equation of the straight line. And guys, do you see what you can tell me immediately here? m is equal to, in other words, the gradient is 3 over 2. My c value is 3, which means, in other words, that my y-intercept is going to be equal to 3. All right, very important, very, very important. When the graph cuts the y-axis, it's going to cut it where y is 3. And this is very important. Where y is 3, on the y-axis, we are going to cut where y is 3. That's where the graph is going to cut the y-intercept. So if you look at this method that I was talking about here, the dual intercept method. The dual intercept method is about getting the y-intercept and the x-intercept. That's what we want to calculate. And then by using these two intercepts, we simply sketch the graph using the two intercepts. That's done. But guys, the only time we use the dual intercept method is if there is a constant that is not 0. If constant is not 0, in other words, if c is not 0, that's when we use the dual intercept method. Because remember, when c was 0, we had no other way than to use the table method. It is the method that works. But if c is not 0, hi guys, we don't waste time. We use the what? The dual intercept method. So the y-intercept we already know. All right, but I just want you to note something here, and this is the following. Whenever we are calculating the y-intercept, okay, besides identify it from the equation, if we are calculating the y-intercept, we must let our x be equal to 0 for the given equation. So let's just rewrite the standard form of the equation that we've just gotten. 3 over 2x plus 3. Okay, so we are going to let x be equal to 0 for this equation because this here gives us access to finding the y-intercept. Okay, so we have y is equal to 3 over 2x plus 3. So if we let x be equal to 0, what happens? Y is equal to 3 over 2. In the place of x, we write 0 plus 3. What does that give us? Y is equal to 0 plus 3. So that means y is equal to 3. And simply put, guys, if we were to write down the coordinates, remember, what did we let x be? We let x be 0. What is the value of y correspondingly? Y is equal to 3. That is our y-intercept. After getting the y-intercept, let us now quickly calculate the x-intercept. When we are calculating the x-intercept, we don't let x be equal to 0, but rather we let what? We let y be equal to 0. I repeat. When we are calculating the x-intercept, we don't let x be equal to 0. It's like in opposition, this thing. When you calculate the y-intercept, you let x be equal to 0. Okay? Because remember, the y-intercept is basically, we are going to be cutting across which axis if we are calculating the y-intercept? We're going to be cutting across the y-axis. And what did I say to you earlier on today? I said, along this y-axis, the value of x is always going to be what? 0. Hence, the equation of this vertical line is x is equal to 0. So x is equal to 0 everywhere along this line. The value of x on this line is 0. All right. So that's why when we are calculating the y-intercept, we let what? X be 0. And then when we substitute, we get a corresponding y value, which is 3 in this situation, which basically agrees with what we would have calculated as our y-intercept. Now we want the x-intercept, where the graph cuts the x-axis. And remember, on the x-axis, everywhere on this horizontal line, the value of y is actually equal to what? 0. That's why we let y be equal to 0. So let's go to the equation. Let's just write it again. And then let us apply, let y be equal to 0. If we let y be equal to 0, in the place of y, we write 0 is equal to 3 over 2x plus 3. Now, you've seen solving for x for an equation like this. So what do, guys? It's simple. We take the positive 3, we transpose it. Ribone, hello Ribone, I see you there. We take, thank you for the follow. We take the positive 3 over to the other side, becomes negative 3. Then after doing that, what do? We want the value of x, remember? Hello Simfu. So after that, we can go ahead and divide both sides by 3 over 2. That's one thing we can do. Or we could do this. Remember that 3 over 2, we can also multiply 3 over 2 by 2 over 3. It's reciprocal. We can do that left and right. Guys, doing this or doing that is the same thing. Okay? Because remember, what's the intention of multiplying by the reciprocal of 3 over 2? Okay, it's so that at the end of the day, we want to do what? We want to get rid of the coefficient, which is 3 over 2. Okay. Yes, Simple, it is. So 3 over 2 times 2 over 3. Okay, this cancels, and we are left with 1x, which is what we want. Then you can say 2 over 3 times negative 3. That gives you negative 2. So therefore, our x value is negative 2. If you did it the same thing here, I mean, you divide by 3 over 2, of course. This is negative 3 divided by 3 over 2, which is the same thing as negative 3 times 2 over 3. Remember that? When you have divide, you change the divide to multiply. The second fraction, it becomes a reciprocal or the inverse of the fraction that we had. This is something you learned in earlier grades, which is something you should know even now. And obviously, this gives us an x value of negative 2 as well. So that's why I'm saying, right? Please, guys, note, both skills are fine. If you want to divide by 3 over 2, go ahead. All right. If you want to multiply 3 over 2 by 2 over 3, it's reciprocal. What you do on the left, you do on the right. Remember, if you multiply by 2 over 3, you have to multiply by 2 over 3 the side as well. If you multiply these two, you get negative 2. All right. Guys, either way, it's 100% fine. All right. And it's nice when you have skills like this to be able to solve things. Either way, 100%. Okay, do we see this? I hope you see, guys. 100% on point. So that means when x is negative 2, remember we let y be 0. So this is our x-intercept. X is equal to negative 2. These are the coordinates of the x-intercept. This is our y-intercept, but these are the coordinates of the y-intercept. You see, y is equal to 3. It means the y coordinate is 3. Who did I let x be? 0. That's why x is 0 for my coordinates. I let y be 0. Who is 0? Y. What's the value of x that I got? Negative 2. Now I can use these 2 points and sketch my function. And it's as simple as that. All I do is I draw my Cartesian plane and I go and identify 0 and 3. That's all. So I have 1, 2, 3. Here I have negative 1, negative 2, negative 3. I have 1, 2, 3. I have negative 1, negative 2, negative 3. And all I want to do here is I want to first go and identify 0 and 3. Remember, when x is 0, x is everywhere on this y-axis. Where is y is equal to 3? That means we're meeting here. That's where we are meeting. You see, so 0 and 3 is there exactly. I repeat, where is x is equal to 0? It's everywhere on this vertical line. X is equal to 0 everywhere on this line. But then if I say y is equal to 3, now I stop there because that's where we are meeting. We're meeting at his house. All right. Then let's go to this point. X is equal to negative 2, y is equal to 0. Where is x is equal to negative 2? X is equal to negative 2 is here, but it's everywhere on this vertical line. Remember, our x value is on this vertical, everywhere on this vertical line. But y is equal to 0. Where is y is equal to 0? It's on this line. So where are we meeting? We are meeting there. You see where we're meeting? And guys, all I do is I take my straight line, my ruler, I just draw a line through those 2 points. Done. Finished. Finished. Finito. Clar. Okay. Yes, at her house, at his house. Very important, that thing. Okay. Very important. Okay. And it's very important, guys. Very, very important. So then all you do, you take your ruler, you just put it like that. Straight line. You exceed. Please, guys, when you draw that straight line, don't draw a straight, just exceed that point, because this is a unrestricted infinite line, okay, through those 2 points. And you just label our function y is equal to, in that standard form, y is equal to 3 over 2x plus 3. Yeah, look at that. The gradient was positive. Wasn't I expecting an increasing straight line? I was. Y-intercept is 3. Look. The graph cuts at 3. Hi. I don't know about you guys, but I feel accomplished. Okay. Right, that's it, grade 9s. That's it. Okay. That's it. So that is the content of how. Okay. That is the content. Why is 2 positive? I don't understand what you are saying. Which 2 are you talking about? I am so lost. I'm lost about what you are asking. So you need to be specific with me. Yeah, and unfortunately, I was going to invite you on so that you can speak your word, but I can't because you don't have live access. So I don't understand what you mean. Why is 2 positive? Where is there a 2 that is positive? Because this x is negative 2. I don't understand what 2 you are talking about. This is an x that is negative 2, you know, and then this is a y that is 3. And that's coming from, okay, y is 2 positive. How is it supposed to be now? Okay, I'll allow you guys to screenshot the pages. Just wait. I'm just trying to understand what Tebe is saying. This was the equation that we had. Now we have 2y minus 3x is equal to 6. We're trying to get this equation in standard form. So what do? We transpose the negative 3. The negative 3x becomes positive 3x when we transpose it. That's mathematically what we do when we are transposing terms from left to right or from right to left on the equal sign, across the equal sign. Then we divide both sides. The 2 here was positive, so we divide by positive 2. If the 2 here was negative, we would have divided by negative, but the 2 here is positive, so we divide by positive 2. But what we do on the left, we do everywhere on the right for each term. So we have 3 over 2x. Here we have 6 divided by 2, which is positive 3. So I don't know why you feel that that 2 should be otherwise. Unless Kutlwano, you have a misconception and it needs fixing. What are you saying to me, young man? What kind of young woman? Okay, so here's a new op on the list alert. Let me just settings. I just want to remove the comments so that you guys can take your screen shottings. Right, so that is the top part. Okay, the top part where we sketched the graph. Remember, we sketched the graph where C is evidently 0 using the table method. When C is equal to 0, we don't waste our time, we use the table. All right, and we can use the arbitrary points -1, 0, and 1 so that we can get corresponding y values, ordered pairs, and sketch, right? And remember, what did I say about this particular one? You have to make sure that the points are equally spaced so that your sketch can come out nice. Okay. Then if we look at this one, all right, this here was a situation where when we took the equation and we wrote it in standard form, we can see that we have a c value that is not what? That is not 0. If the constant is not 0, then we need to use the dual intercept method. Dual intercept method is what calls for us. And remember, guys, you need to check what is the instruction that they give you in that particular question as a grade 9 learner. If they say sketch the function using the table method, you use the table method. If they say sketch the function using the dual intercept method, you use the dual intercept method. But if you are not given an instruction and you see that the c that is 0, guys, table, please, straightforward, because it's the only way where you can see the entire picture. If the function has c that is not 0, guys, dual intercept method. Don't waste time. Dual intercept. Okay, unless stated otherwise, dual intercept. Okay, so this is basically how we went about finding the y-intercept, the x-intercept. All right, we found our x-intercept when we let y be equal to 0, got the coordinates, and then when we let x be equal to 0, found the coordinates, and then voila. Please, guys, remember we let x be 0, so our coordinates 0 for x, 3 for y. Here we let y be equal to 0, means 0 for y, x -2. Okay. All right, I think we can, I hope you've screenshotted enough here. And then yeah, this was the notes at the beginning of the live lesson, where we are looking at, well, beginning of the live lesson from like the beginning part 1 that is already uploaded, but this is just for you guys so that you can be able to see basically where we are referring to. And these are the notes that I said you need to have up in your wall somewhere. You need to remember this for this term and forever, actually, forever in your maths journey, pure maths journey, and then here as well. Okay. All right. Yeah. Maybe you guys can do this one. Sketch the graph y is equal to -2x. You can do that for yourselves. All right, please do that just for practice purposes. Okay. And then here's another one. Okay. This one, 2y minus 4x is equal to 8. You can sketch that function as well, just for practice purposes. Okay. And then one more thing. I think for the purpose of those who want to also get into the game a little bit more, these were some find the gradient between the following pairs of points. All right, I went to, guys, ChatGPT is very resourceful. I went to ChatGPT and I was like, can you give me some problems? I literally typed this, like, give me some problems to finding the gradient between 2 points, 15 problems. And then ChatGPT gave me this. So I thought to myself, might as well just share this, and probably will post it also on the actual page so that people can have a shot at this, and you can flex your muscle and use the gradient formula to see if you can calculate the gradient, identify the points, point 1 and 2, use y2 minus y1 x2 minus x1, and check if you can get the values. Also, it tests your algebra skills, your signs, your addition, subtraction, multiplication, and so forth, because those are important skills you need to continuously have in mathematics. Okay, I think that basically wraps it up for us today, and I think that's it. So until next time, till you and I meet again, under different conditions, we'll see each other. Kutwano, you're welcome. I am glad you do understand, and I hope you understand now and forevermore. And thank you so much for those that joined. You guys were phenomenal, great audience. I hope you guys learned a lot, and that, yeah, it will solidify your function skills. You will remember this comment earlier on. This learner, funny enough, what's nice is me being able to assist learners across the country, which is very nice. So there was a learner that's called Aiden that came onto the live and said that functions are hell. I think he pretty much put it not very nicely, but in that way, that functions are hell. He's a grade 11 learner. Funny thing is that very same learner had sent me a message, I think it was during the holidays, and had indicated to me that in term 1 the results had gone up, because he was he felt like the live lessons had helped him significantly, so his performance was really like up there. And I think he had posted even the percentage that he had gotten for that particular whatever. Yeah, he said functions are the devil. And I'll tell you this, guys, most people do believe they are because they don't understand the basics. So you guys just need to tune in to the things that I'm emphasizing over and over again. I will, in these live lessons, make sure that I unpack functions so that they become familiar, easy, and easy, because they are easy. Functions are easy. But the problem, I think, is, most learners get exposed to functions in grade 9, but weakly so, in a weak way. They don't, not for a long period of time, with much explanation, with opportunities to really do problems and do them over and over again, so that people can actually have, a solid conceptual foundation. So as we have these sessions, I'll give you a chance so that you guys can actually really, hopefully you are listening to me, hopefully you're taking down notes, hopefully you go back, you check out exercises in books, you go to websites, you download papers, you write, you actually attempt questions that you get from papers. There's websites, guys, galore of past papers, GEC papers, past papers. On my platform, both the Maths is a Game platform, this one, and the other Maths is a Game platform, you guys can go and check out GEC papers that I've posted as pictures onto my YouTube channel, onto my TikTok pages on the homepage from last year, 2024 and 2023 GEC. Then you can check out the function questions and just get familiar with how function questions are asked. If you can do that for yourself, you'll do yourself a big favor, and you'll actually see that this is actually not as bad as people make it out to be. And then functions in grade 10, okay, they will be that much more easier, okay. So yeah, Mia, I did domain and range for grade 10 long time ago. Long time ago. I did that, Mia. I don't know now for how long you want me to do domain and range. So let me end this live, Mia. Let me end this live, and then I'll do another quick live for you, like a maybe 15-minute explanation of what domain and range are for grade 10. Okay, so let me end this. You just need to join in, because I want to save this video for the grade 9s, not sort of like mix it up with grade 10 content. So let me just end this live. That's great, TTK, that you guys are the first time doing GEC. It's quite easy. You just need to, like I said, guys, even on my I have a WhatsApp channel. So if you go to my other WhatsApp page and you go to my WhatsApp channel, on my WhatsApp channel I've posted the pictures of the previous past GEC papers in 2023 and 2024. Get familiar with questions and how they are asked. I even posted past, even before that, GEC papers. So you guys need to get familiar with that.